You have typed thousands of URLs in your life, but most people don't actually know what happens after you press enter. Today we are going to trace every major step from your keyboard to the server and back to you without any fluff and without any buzzwords. If you really understand this, networking, performance, debugging and interviews all becomes easier. So now we will get to know 7 stages which is responsible for rendering you the data from the URL. So those things are DNS, TCP, TLS, HTTP, server processing, response and browser rendering. And I will also tell you where things fail in real projects and not just theory. So let us go to the step 1, that is URL parsing. As soon as the user enters the URL and press enter, so the browser basically just doesn't go to google.com. So it basically breaks it into parts like protocol, domain, path and query params. So the protocol is nothing but HTTP or HTTPS, and the domain will be like google.com, youtube.com or any domain which you want to visit. And the path will be after your domain name, whatever you append it with slash becomes the path, and after path whatever you append with question mark and the further part becomes the query parameters. So this matters because each part affects different part of the system like security, routing and caching. Let's go to the second step, that is DNS lookup. So computer doesn't understand domain names. They understand only IP addresses. So the browser asks what is the IP address of www.google.com or youtube.com. So the DNS resolution order looks like, first it will check the browser cache. If there is already a cache data, it will be fetched from that. Then if there is no cache data in browser, then it checks the OS cache. Then the third step is router cache. So in router cache, if it finds, it will be rendering from that, or else it will be going to your internet service provider's DNS. So if it didn't find there also, then the final option is it will go to the authoritative DNS server. This is why a site loads faster for the second time when it is already cached. So the real world failure point in this section is you need to check, like, if the DNS is very slow, then the websites will be loaded very slowly. This is why companies use CDNs and DNS providers so that it will be resolved as soon as possible. Now the third step is TCP connection. Now the browser knows the IP address of the domain, but it still can't send the data yet because it needs to perform a connection. So it establishes a TCP connection using a concept called three-way handshake. The three-way handshake is nothing but it's a first the client will send a synchronized request where the server accept acknowledges the synchronized request, and in return it sends its own synchronized request, and the client at the end it will send this acknowledgement for that synchronized request. So that is how a three-way handshake works. This ensures both sides are ready to talk and are reliable. This reliability is why HTTP works and also why TCP has a slight overhead. Now the step 4 is TLS handshake. Basically there is a little bit difference between HTTP and HTTPS, where HTTP is like secure, which uses a SSL certificate for authentication. So basically TLS ensures encryption, authentication and data integrity. What happens actually is server sends a certificate, browser verifies it, keys are exchanged, encrypted channel is created for a safe data transmission. This is why HTTPS is little bit slower than HTTP, but it is non-negotiable in production because of security. After the TLS verification is done and there is a secure channel done between client and server, the browser sends an HTTP request. It includes what type of method is that request, like get, post or put or delete, and some headers related to the request, and also few cookies and also few query params. So this is the example which you can see in the screen how the ideal request looks like. So Once the request is received by the server, so server does few processing. On the server side, the request will be hit through a load balancer, and the load balancer will be routed to an the request from the load balancer will be routed to an app server. Then it goes through the authentication and authorization part. If there is some validation, then some business logic happens and database calls happen. The last thing is response will be prepared and then it will be sent back to the client. This is where most latency actually happens, because there can be flaw codes which makes the database calls or some business logic to execute, which will take a lot of time. So now the step 7 is response will be coming back to the browser, like the server sends back the response in the below format, where it will have a status code like 200 is for a successful response, 404 is when the page is not found, and 500 is for some internal server error, like if there is some error on the server side, it will also be sent. And there will be some response headers as well, and the body type will also be there, like it will be a HTML, or if it is a API then it will be returning in a JSON or a XML format. At this point networking is done, but the page is not ready yet, because there is one final step, which is browser rendering pipeline. So this is where browsers do the real work. So HTML data will be passed to the document object model, CSS will be also passed, then both will be merged to a render tree, then the layouting happens and it will start painting the layout on the browser. This explains like why large CSS files slows down the page loading, and also why JS is dangerous, like if there is some blocking code, why it will stop loading the page fast. Why performance issues aren't always the backend problems. There will be also some client side programming which will make the page load very slowly. So one bonus tip is JavaScript execution. So after everything got painted, then only the JavaScript starts its execution. So there will be multiple things like event loop, call stack, async tasks, API calls. This is why a badly written JavaScript can make a fast server feel slow, because it will start executing the thing on the client side and the client will be waiting for the page to be loaded until the JavaScript execution is completed. So the final takeaway is when you press enter, it's not just one thing is responsible. It's an entire distributed system working together. If you understand this flow, debugging becomes logical, performance tuning makes sense, system design also clicks. If this cleared up few things for you, like the video, comment which step confused you most. I will make a video just on that, or I will try to reply on the comment. And thank you. See you in the next video.